Hey, this is a video for 5.5, Irrigation Methods. So go ahead and check out the overview and set up your guided notes. So the United States uses a lot of water, and you don't really have to know, this is a graph that I'm going to show you, but you don't have to know the actual amounts, which is why I didn't put percentages in there. But you should understand that relatively like where most of our water is going. So the majority of our water goes for thermoelectric power, and that is related to boiling water to generate steam, and that steam turns a turbine. That water is fresh water, and it's almost half of the water that we use. The next amount is for irrigation. Now, this water for irrigation, we'll be discussing all the different methods in this video. Then we have the water that is in the public water supply in cities, and we have self-supplied industrial. So this is for manufacturing, for example, that obtain their water, like maybe from a well, for example. Then we have aquaculture, which we'll discuss in a future video, but it involves raising fish, basically farming fish. Then we have mining, which requires a lot of water. And the smallest amount of freshwater use is for our homes, self-supplied domestic water. So this is the water that we use, like for example, on a farm digging a well. Now globally, this is the freshwater that we are withdrawing from aquifers. And recall that aquifers that's water that is underground, and it is groundwater. So this is where we are withdrawing the water from. So 10% of it is for municipal or use in cities. 20% of it is for industrial purposes, and 70% of this water is for agricultural purposes. So the first method is furrow irrigation, and furrow irrigation is where you dig these channels between the rows, so the plants would be on these raised mounds, and the idea is that the water will soak in where the roots are. Now this is only 65% efficient. You don't really have to understand the percentages because there's a lot of discrepancies. Some different sources say different amounts. I haven't really found, it's really frustrating looking because you can't really find a reputable source that will give you an actual number. The different textbooks have different amounts. But generally speaking, furrow irrigation is the least efficient method. Again, it involves very little labor. You literally just got to dig a channel and then add water. You turn on the hose, let the water run, shut it off when there's enough. Like, that's very easy. There's a lot of evaporative water loss. So 35% of the water, in other words, that doesn't go down and infiltrate into the soil will evaporate. It can also lead to waterlogging and soil salinization. And I'll explain what those are right now. So waterlogging, this represents the soil particles. Waterlogging is simply depriving the roots of a plant of oxygen. So if you assume that we have the aquifer underground, the top of the aquifer is called the water table. So when we plant our plants, some of the roots go beneath the water table, but some of them just, reach down, dip their toes in the water, so to speak. Now this allows oxygen to get in these pore spaces, and it allows them to draw up water from beneath the water table. However, when we add a lot of water, we can cover the roots, and we are depriving their gas exchange from occurring within the roots. And this can lead to buildup of anaerobic bacteria. If you have house plants, you maybe heard of root rot. That is something that can happen with the plants, and it can lead to their death. Now, soil salinization is something different. All the water that we give our plants has some tiny amount of salt in it. So there's going to be salt left behind after evaporation. So we add a little bit of water from a sprinkler, for example. And if we keep adding water, the more and more water we add, when this water evaporates, it's leaving behind salt. And this can change it can affect the osmoregulation of the plants. It can also lead to dehydration of the plants, and the conditions of the soil will be outside of the range of tolerance for many plant species. So going back, another method of irrigation is spray irrigation, and that's when you use pumps to, basically you're using a giant sprinkler to add water to the field. This is between 75 and 95% efficient, depending upon the method. Again, it is very simple. You can target specific areas, so you don't actually have to flood the entire field. But you require energy in order to pump the water, and it can still lead to evaporative water loss. Granted, it's not as much water loss as the furrow method. Now, flood irrigation is anywhere from 70 to 80% efficient, and that's literally where you flood the entire field with water. And this looks pretty wasteful because it is. But there's really no labor involved. Like, you don't even have to dig a trench. You literally turn on a hose and turn it off. You can even set a timer. But there's going to be a huge amount of evaporative water loss, and also leading to soil salinization and waterlogging. So whenever you have high evaporative rates, you run the risk of salinization. Now, drip irrigation is the most efficient. It's when you have water being delivered pretty much directly to the roots through tubing that is buried in the ground. And this is the most efficient method. It can target individual plants. However, it is very, very, very expensive to set up, so it's cost prohibitive for a lot of smaller agricultural organizations. And the tubes likely have to be moved in order to harvest, or you have to bury them much deeper into the soil. So, reviewing again aquifers. So an aquifer is just the area of water that is stored in the pores between the soil particles, and at the top of the aquifer is the water table. Now you have maybe two houses, and they both have wells, so they're withdrawing the water. But then you have a farmer that comes by, and this farmer is a big industrial farmer, and maybe they got really powerful pumps that can suck up a lot of water. Well, what happens is you can get what is called a cone of depression, and that is when there is extensive water reduction from pumping and from pumping from a well, and it can lower the water table. So basically, this is an example of a tragedy of the commons. Taking up all of this water is making it unavailable for neighboring wells. And when you over withdraw the water, some of the impacts is you can have subsidence, which is basically a sinkhole. Because the water, when it's up high like this, the water may exert some pressure up, and it may support some of these houses. But when you withdraw too much, what happens is you might have a house sink. So you get a sinkhole. You may have seen some sinkholes on the street, like it looks like a big giant pothole. That's where the soil gives out and everything sinks and compacts. You can also, neighboring wells will run dry, like I've said, and that can decrease productivity, decrease profit, but also you can get saltwater intrusion. So saltwater intrusion occurs in coastal aquifers, where you have the fresh water from the aquifers and you have the salty water coming from an estuary or from the ocean. Basically, their pressures are equalized. So in this example, the pressure coming from the fresh water is equalized by the pressure pushing in from the ocean. But when you take a lot of water away, you're lowering the amount of pressure that this fresh water is providing, which means that there's higher pressure coming from the ocean, which will then push that salty water into areas that are agriculturally active or into arable land space. When this happens, this can impact the productivity of the land, and it also means that a lot of these plants, the conditions are outside of their range of tolerance. Now, aquifers need to be recharged, and when you have aquifer recharge, it's when you have water infiltrating through the soil into the aquifer. So again, the aquifer is not a straight line across. Oftentimes it will slope down to a body of water, like a lake or a river. And we have different types of aquifers. We have an unconfined aquifer, and that's basically where it's covered by soil, and it has a very easy recharge. Recharge is when you're adding water back to the aquifer. This infiltration occurs very easily. Now, when you have a confined aquifer, that would be right here. It is covered by something impermeable, whether it is clay or a layer of rock. It is allowing recharge only in one tiny area. So if it rains over here, the aquifer, the unconfined aquifer, will be recharged. But the only way to recharge this confined aquifer is from this little tiny space. Now with an with a confined aquifer, you can also get what is called an artesian well. That is when you have the water table in a confined aquifer is higher than a well or an area where the aquifer is exposed. So what happens is the water is pressing down. There's a lot of pressure pressing down, and then as it presses down, there's only one place for this to go, and it rises up. So this is called, again, an artesian well. So you have a positive pressure, and it's an automatic flowing well. Some of the spring waters that you may have drank, I don't even know if Poland Springs, but some of them come from artesian wells. Now, one famous aquifer that we have in the United States in the Great Plains is the Ogallala Aquifer. You'll need to commit this to memory because this does show up. It's basically underneath Nebraska, Kansas, Oklahoma, parts of Texas, into Colorado. I think I gave every state, maybe Missouri and Iowa. I forget exactly how many. There's like 7 states that it involves. You can look on a map with state boundaries, but it's predominantly around Nebraska, Kansas, Oklahoma, and part of Texas. Now, we have done so much withdrawal because it's a relatively arid area, and we are withdrawing more water faster than it can be recharged. So a big problem is the Ogallala Aquifer is being depleted, and this is a major example of tragedy of the commons. So I gave you a lot of information. Respond to this check for understanding. And now let's practice our FRQs. Explain how irrigation can lead to biodiversity loss. I hope that this video was informative. I thank you for your attention, and I will see you soon.